Okay, let's look at part C of this problem. So we have our new function. I'll call it g of x just to give it a different name. So c g of x is equal to x times the square root of 6 minus x. So same idea as last time. I'm going to find the two derivatives first. G prime of x is equal to first times derivative of the second. So I'm going to go through this really quickly, but that's going to be minus x over 2 root 6 minus x. And that just comes from the fact that this is x times 6 to the minus x to the 1/2. So I use that together with chain rule. Minus, or plus, second times derivative of the first, which is just regular old square root 6 minus x. And I think the easiest thing to do is I'm already going to have to do quotient rule anyway, or some variant of that. And I'm going to have to solve for zeros, so I'm going to want everything over one fraction anyway. So I think it's a little bit easier to go ahead and multiply, get a common denominator now. So 2 root 6 minus x, 2 root 6 minus x, multiplying by a useful form of 1. And I get that this is equal to minus x plus 2 times 6 minus x, because I have root 6 minus x times itself. And then finally I have 2 root 6 minus x on the bottom. So I get minus 3x because I have minus x, and then minus another 2x, all divided by, plus 12 divided by 2 root 6 minus x. And then g prime prime of x, now I can do quotient rule for the derivative, or I can try writing this as first minus 3/2, and then I have x plus 4 over root 6 minus x. So I divided the top by 3, as well as took the minus, which actually makes this an x minus 4. Instead of a plus. So x minus 4 over root 6 minus x. I took the 2 from the bottom of that. And now we're left with this function. And this one shouldn't be too bad to take a derivative of, but I think it would be easier to rewrite this as minus 3/2 times x minus 4 times 6 minus x to the minus 1/2. So instead of doing quotient rule, I'm going to do another product rule. Let's see. This is still g prime of x. Sorry, I haven't even taken a derivative yet. So g prime prime, g double prime, is going to be equal to minus 3/2 first times the derivative of the second, x minus 4, times minus 1/2, 6 minus x to the minus 3/2. And then we're going to have times minus 1 because that's the derivative of the inside function, so that's chain rule. Plus second times derivative of the first, that one's easier. 6 minus x to the minus 1/2 times 1. And that's what we get from there. So this minus 1 and this minus 1/2 cancel, in a sense. The minus 1 cancels with the minus from there. And I'm left with equals minus 3/2 x minus 4. And I'm going to write this 6 minus x to the 3/2 like this. 6 minus x to the 3/2, going to write it down there. Plus 6 minus x to the 1/2 over 1, because there's nothing else there. And I'm going to get a common denominator for this actually, so that way I can look to find zeros. So 6 minus x times 6 minus x will give me the same powers. And I get equals minus 3/2 x minus 4. Now I know I'm going to have the same denominator, so I can just write plus 6 minus x over 6 minus x to the 3/2. And now this cancels beautifully. I'm left with minus 3/2. X minus an x is 0. 6 minus 4 is 2. So I get 2 over 6 minus x to the 3/2. And that's my answer there. So I found g prime of x, found g double prime. Now I go ahead and find my critical points. So again, g prime of x was, this had the minus 3/2. Also, it's not a big deal, but those 2's cancel. But I had minus 3/2 times what? X minus 4 over square root 6 minus x. So we have a critical point at 6, because that's where the denominator is 0. And when x is equal to 4, because then the numerator, so the function, is equal to 0. And those are the two places where we have a issue. And one thing to keep in mind, this function is only defined if x is bigger than 6 anyway. So there's no reason to check on the other side. So critical points at 4 and 6. Yeah, so this x minus 4, sorry, if x is bigger than 6, this function stops being defined. So we hit a hard stop there. So we're allowed to plug in 4, but we can go ahead and stop at 6. So minus 3/2, I'm going to tally down, x minus 4, square root 6 minus x, and I called it g. So g prime of x. What are my issues? Minus infinity, I can plug in any negative number I want, up to 4. And then I have a hard stop here at 6, so I drew that a little too big. But if I plug in, say, 0, well, that square root is always going to be positive anywhere it exists, because it's a square root and it's not 0. X minus 4, if I plug in something smaller than 4, is negative. If I plug in something bigger, it's positive. And I write down the minus 3/2 because sometimes I forget that constant's out there, so that just makes sure that I keep it written down. So that doesn't give me any issues. So here I get its positive, here I get its negative. So this function is increasing from minus infinity to 4, and it's decreasing from 4 to 6. And we should have a maximum at that 4 place. So local max at 4 comma f of 4. And what was our original function? X times root 6 minus x equals 4. 4 times root 6 minus 4 equals 4 times 4 root 2. So we're going to have a local max there. And that's by the first derivative test. We were increasing, and then we were decreasing. Next, we need to take a look at the second derivative. So that's g prime prime of x. And let me remember what I wrote down there. It was, oh, this simplified really nicely. minus 3 halves times the 2 over 6 minus x to the 3 halves. Yeah, this one's nice and easy. Because, well, what happens? We have minus 3 over 6 minus x to the 3 halves. Only has a critical point at x equals 6. But x is already not defined if x is bigger than 6, or f of x is not defined if it's bigger than 6. So therefore we get this really weird looking function or sign chart where I just say, okay, from minus infinity to 6, I don't have any relevant critical points, so just plug something in. So say I plug in 2. On the bottom I'm going to get a positive number, and then that minus 3 is going to make it negative. So this function is going to be concave down everywhere. Minus infinity to infinity. And that's 10c.